Anu ma'am? Dindiyastri?
Yes, sir.
Okay. Because it was so silent, so I don't know whether it is audible or not. So thank you.
Okay, sir. Okay.
Good afternoon, Dr. Tamilchelvi.
Good afternoon, sir.
This is Robin from PALS, ma'am. How are you, ma'am?
Thank you. Fine, sir. Fine.
Thank you, ma'am. Thank you, ma'am. Thanks for joining.
Okay. Thank you.
Good afternoon, Dr. Balasubramani.
Good afternoon, sir. Good afternoon.
Okay. Thank you, sir. Thanks for joining.
Okay, thank you.
Anu ma'am, are you there? Anu ma'am? Miss Anuradha?
இல்ல நான் கூப்பிட்டேன் உங்களுக்கு கேட்கவே இல்லையே. ஓகே இப்பதான் கேட்குது. ஓகே ஃபைன் ஃபைன்.
Welcome, Dr. Balasubramaniam from TC.
Ma'am, Dr. Tamil Chelvi and
Tamil Chelvi,
Dr.
yeah.
Balasubramani has already joined.
Yeah, I'm seeing it.
Good afternoon, madam.
Good afternoon, Tamil Selvi. Went to get some water.
Good afternoon, Mr. Ravichandran.
See if Mr. Tamil Selvi is there. Unmute.
Good afternoon, Mr. Ravichandran.
Yes, sir. Good afternoon.
Good afternoon, sir.
Good afternoon.
Thanks for joining, sir.
Really a pleasure to be with all of you.
Yeah.
Good afternoon, sir. Ravichandran, sir. Good afternoon.
Good afternoon, sir. Good afternoon.
We have Dr. Balasubramaniam from TC and Dr. Tamil Selvi from National Engineering College. So,
Yes, thank you.
Sir, if you don't mind, you can check the video settings, that is able to share your presentation, because I have stopped sharing my screen. So, Mr. Ravichandran,
Yes.
you can start sharing your screen.
So my video is visible. Is it okay?
your video is visible.
Yeah, visible, sir. Good, sir.
Fine.
Fine. Good, sir. Yeah, now it's like
So it's very
Good.
colorful. Yeah.
Fine. Good. Exactly.
You might take another 5 minutes.
Yes, sir. Pardon.
Are we going to take another 5 minutes or so?
Yes, sir. Just we have another 3 minutes is there. Exactly 2:01 will start. Anu ma'am,
Yeah.
you were
How many students and faculty members are expected?
around 150 plus.
Right now we have around 32, if I'm right.
Yeah, they will join. Yeah, they will join. Once we
Are
start
we
the
to wait
session.
should we wait and start at 2:05?
Yes, we can.
Yes.
Okay.
I will be on mute mode till 2:05.
Sure, sir. Sure. Thank you.
Thank you.
Robin
Hi, Arun.
Strata here. Robin,
Yes.
hi Anu.
Hi.
Yes, ma'am.
KIT, TCE and NEC are presenting, right?
Yeah.
Yes.
So I hope they have, the teams have informed your students in your college. Are they all participating? Are there any student leaders from TCE and NEC and KIT here?
I think
Ma'am, good afternoon, ma'am. I am from TCE, Prabhakar.
Good afternoon, Krupakar.
Yes, ma'am. We have informed all our colleagues, ma'am. They will join in a minute, ma'am.
Yeah,
We
can
will
you all
join soon,
hurry
ma'am.
up because the speaker is here and we should, because we don't want to cut short your time. You need that 15 minutes of your presentation time, right? You've all put a lot of hard work for getting that stuff done.
Yes, ma'am. I will insist it, ma'am.
Thank you, Krupakar.
Thank you, ma'am. Thank you, ma'am.
Arundev
KIT?
is in. Can you make him co-host?
Yeah, I have done it.
I've done. Hi, good afternoon, everyone.
Okay.
Good afternoon.
KIT, any representatives?
Ma'am, yes, ma'am. They will be joining in a while.
Who was that? Bhavya.
Yes, ma'am. Bhavya here.
Hi, Bhavya. So they're all joining.
Yes, ma'am.
Can you ask them to please hurry up?
Yes, ma'am. Sure. Just give me a minute, please.
Sure. National Engineering College?
Yes, madam. Students are here, madam. Students joined already.
They've already joined?
Yes, madam. Yes.
Yes, they have joined.
Not the team, I mean. I'm talking about...
The audience.
Yeah. You can alternatively tell them that YouTube link is also on. So the live streaming is going on there. They can watch it if that is convenient. Who's the MC, Robin?
Sneja and Dindyastri.
Sneja and
Dindyastri.
Dindyastri. Dindyastri is from TCE.
Sneja is
Sneja.
from NEC.
NEC. And college management representatives from TCE is Dr. Balasubramani, is it?
Yes.
yes, madam. Yes, madam. Yes, madam.
Good afternoon, sir. Welcome.
Thank you, madam. Thank you.
And
From
Miss
NEC?
Tamil Selvi. Miss Tamil
Dr.
Selvi
Tamil
from NEC.
Welcome, ma'am. Welcome, ma'am.
Yes, madam. Thank you.
We have 2 more minutes to start.
Probably you can ask them to, name themselves and all that stuff. You can finish now.
Yes.
Guidelines.
Shall we start?
Yeah.
Okay. Yeah, good afternoon. I'm Robin, PALS Program Management Office. Campus event, PALS Aspire on Core Conventional Engineering, hosted by National Engineering College and Tyagaraja College of Engineering. I would request the MC of the day, Sneja and Dindyasri, to take care of the proceedings. Thank you. Sneja and Dindyasri.
Good afternoon, one and all. Yesterday was a dream, and tomorrow is a vision. But a day well lived makes every yesterday a dream of happiness and every tomorrow a vision of hope. With the same vision, I welcome you all to the PALS Aspire event. I'm Dindyasri from Tyagaraja College of Engineering.
I'm Sneja from National Engineering College. We extend a very warm welcome to our Honorable PALS champion, our host, college members, and all the participants. I request everyone to mute yourself.
For attendance purpose, please type your name, hyphen your college short name, hyphen student or faculty in the chat box. Example, Ramesh hyphen Ramko hyphen student. Please type this in the chat box for attendance purpose.
I now invite Mr. Emmanuel Robin Joseph to deliver the welcome note.
My God. Robin, you're going to welcome everyone.
Yes, I welcome the participants and the teams and the audience and the dignitaries. So it's a campus event, PALS Aspire for Conventional Engineering. I request Ms. Anuradha to give an intro about PALS.
Good afternoon, everyone. Thank you for being here for this session. And a quick intro about PALS. It's an educational initiative by alumni of different IITs. And it's an educational initiative. We are here to conduct this campus Aspire session, which covers core engineering subjects. This time we thought paint is a nice subject which cuts across different disciplines, and we also had the advantage of having Mr. S. Ravichandran as one of our contacts through our industry partners, and he is from his introduction you will know that he's from he's stayed quite a long time in the area of paints, and he lives out of Kolkata, and he's joining us from there. And PALS, as you know, have several other programs, and we are yet to complete one theory to practice and one acquired session on the latest engineering subjects, and also the Innova finals, which is expected shortly. So I thank everyone for being here. Now we are running close to 87. I hope we will touch 150 as mentioned by Robin earlier. I welcome Dr. Balasubramaniam and Ms. Tamil Selvi, who are going to host this session, and I pass the baton back to Dindia and Sneja.
Thank you, ma'am. It gives me immense pleasure to invite the first host college of the event, National Engineering College. It provides a chance for the rural students to shine bright. I gladly welcome Dr. S. Tamil Selvi, Professor in EC Department and Dean Academic of National Engineering College, Kovilpatti.
Thank you, Sneja. So, very good afternoon to all present here. I'm very happy that and to be a part of this today's event, PALS Campus Event Aspire from National Engineering College, Kovilpatti. And I'm also very happy to connect with the people in PALS, Anu Madam, PC Balasubramanian sir, and other all PAL team members today. And so we are very happy that our NEC, National Engineering College, is a part of PALS. As Anu Madam already has introduced the PALS and the activities of PALS. So in our college, NEC actually became the partner institution of PALS in the year 2018. So PALS is providing quality programs for the students as well as faculties for their knowledge upgradation. It also conducts programs, conclaves, brainstorming session for management level persons too. And few student level programs to mention are weekly 2 or 3 campus lectures, theory to practical sessions, which helps students to think out of the box and enrich students' knowledge in the upcoming technologies. So PALS flagship event, a year-long event known as the Innova Product Development Contest, is a remarkable one through which PALS encourage student entrepreneurship. And another remarkable event of PALS is a residential workshop for the students, in which students enjoy their presence in IIT Madras for a week. But this time, due to COVID pandemic situation, our students really actually missed it. And in addition to this, from last year, PALS started conducting analysis, a techno case study analysis event, and as per a discussion forum through which the students' skills are enlightened. And this year, PALS conducted Students Hackathon. So every year, PALS is introducing new events for the benefit of the students. And apart from this, for the faculties, PALS provides quality FDP programs on pedagogy, teaching and learning. And then Meditech workshop at Research Park of IITM, Artificial Intelligence workshop, and PALS also conduct one-day industrial visit for the faculty as well as for the students from last year. And this year, PALS introduced virtual lab facility for the benefit of PALS members. So PALS is doing a wonderful job towards the development and growth of students and faculty. So really appreciate the PALS activities and all team members involved in PALS. So we thank the PALS for providing such a quality programs for the upliftment of student and faculty community. So thank you all for giving me this opportunity. Thank you all.
Thank you, ma'am. I feel honored in welcoming the second host college of the event. Now I invite Dr. V. Balasubramani, Assistant Professor of Mechanical Department from Tyagaraja College of Engineering, to address the gathering.
Good afternoon, one and all present here. I am very grateful to give a keynote address about a PALS event, campus event, Aspire. First, I welcome all PALS members, Anu Madam, Robin Sir, Sujata Madam, and Lavanya Madam, as well as the first coast team members from National Engineering College, Koilpatti, and the next host team of my college, and the third one is Kalaignar Karunanidhi Institute of Technology team members, as well as the students from host institution as well as other institution. I think the PALS every year PALS is conducting many events for benefit of faculty members as well as student members. I think last year they have mostly conducted many events as a face-to-face, as well as one of the PALS event we have organized the same kind of Aspire lecture series in last year during February. But this year, because of a pandemic, so they are conducting new events. Particularly, most of the events are in online mode, as well as it will reach all faculty members as well as the students in a very good manner. So, Tamilselvi Madam listed the many events are conducted by the PALS. Here also I have noted the few events I actively participated, as well as our students also participated. The one event is the Rootag Utsav. The Rootag Utsav is conducted on the 19th December. So I participated as a member of this workshop. I think in this workshop they have given the clear information how to write a proposal. There is how to write a winning proposal to not only the Rootag, even in our ACRB and other government funding organization. I think it's very useful to faculty members how to crack the proposal. As well as I have also participated the theory to practice the yesterday, as well as the similar lecture series I have attended. So all the lecture series are very useful. They have introduced the new concept, or as well as a new thing what is available nowadays. I think it will be very useful to students as well as the faculty. I think this year they have introduced two new event. One is a next gen hackathon, and another one is the Lister digital placement as well as an internship. I think these the three things are very useful to students, and our college members also. So one, and they have involved in the internship as well as the placement also. And then Paul's Carson says they have many lecture series are organized by the Paul's members, and it will be enlightened the ideas by the many resource persons from various institutions as well as various industries. It will be also very useful. So I think I request the Paul's members, you have to organize the same kind of event in a regular year. I think it will be very, very useful to all faculty members of all partner institution, as well as the students of a partner institution. So thank you for organizing this kind of event as a host institution of our college, as well as other host institution, National Engineering College. It is my parent institution. I am an alumni of NEC. This year we are celebrating a 25-year reunion also. So I am very happy to share my views with my the parent institution. I thank all the members. Thank you. Thank you.
Thank you, sir. It is a great honor for me to introduce and welcome the chief guest of this startlingly beautiful noon, Mr. S. Ravichandran, the senior manager from T&D of Berger Paints at their head office. He has served earlier in the capacity of Group Product Manager and National Business Development Manager.
Dear spectators, you yourself will witness a strong commitment and the highest quality of knowledge unfold. Ladies and gentlemen, please give a huge welcome to the speaker, Mr. S. Ravichandran, the Senior Manager of Berger Paints, to address the gathering and give his precious inputs to the participants.
Are we there to start off right now? Is it okay?
Yes, sir.
Thank you very much. And it was a fantastic afternoon presented by Pals to all of us. And I'm equally happy and elated to share my knowledge and experience to the next generation. I think the set time is still 4 p.m. and we are already at 2:17. So I would like to reconfirm till what time I'm expected to speak, so that we can plan our
3:05 or so.
Yeah, please.
3:05.
3:05. Yeah.
Yeah.
That's fine. Yeah, fantastic. So greetings to all the members who are present, number one, and number two, I would like to request the students that I am not going to compete with you with respect to reading a slide, okay? So whatever is there in the slide, I will not be speaking. I will be speaking something more than what has been presented, and I'm sure that you can read the slide faster than me. That is one thing which I would like to share. Number two, whenever you have a doubt, you can put it on the chat box and one of the volunteers can take it up and speak to me. That will be an easy way to do that, so that there will be a single member taking the responsibility of taking your question and asking me. And number three, I believe my English is okay with you. In case if there's going to be any difficulty that I am not pronouncing or speaking well, you can again put it on the comment box. I will try to put it in Tamil language as well, because fortunately I am a Tamilian, though I am based in Calcutta. So with that, I think all of you are comfortable, and we will get into the world of paints. Okay. Just to give you a quick understanding of where I come from, I represent the company called Berger Paints. It's second largest in India, and we are the leader in protective coatings, fourth largest in Asia and 14th largest in the world. It has been awarded the best Indian paint company by Times Business Awards, and we are into all the spheres of industrial paints as well as decorative paints. With that, I don't want to give you more details about this company. It is not going to be of much use unless or otherwise you start having some relationship with it as an employee or as a consumer. Now let us get into the topic of why to paint. When you look at it, there is something which gets corroded or getting deteriorated, and therefore we need to protect that particular structure, equipment, component, pipeline, whatever you call it, and that has to be protected. Paint is one of the most preferred material for offering protection. When you look at nature, nature is so beautiful, and it made man to think and start mimicking nature in all his activities. Colors also is borrowed from nature. Paint naturally has a lot of colors. But when he started making components or structures, be it concrete, he started mimicking rocks. Rocks are there for millions of years, billions of years. And when we wanted to make concrete, we are in no match to nature, but we still could make something better. And the aim of a civil engineer is to make a structure or a bridge or a building which can last, or a dam for that matter, to last for more than 100 years. But it withers off much earlier than expected due to deterioration, the effect of corrosion on concrete, the effect of corrosion on the infrastructure. And this is the challenge what we are trying to work with. Be it metal, metal everyone understand, right? It corrodes. So concrete is what many people do not know, that there is a corrosion happening in concrete. So I highlighted that in the first place. This is how corrosion affects, be it steel or concrete. When it is steel, it is on the surface and it is easily visualized by observing the rust, the flakes of rust. But when it is concrete, you will never know. It is like a cancer in the body. One fine day, it buckles, it cracks, and the load bearing capacity is lost and the building collapses. And this is what happens to concrete. So be it a mild steel or a concrete, coating is very, very important, which will ensure corrosion does not take place. This is how we start the topic. Now, what are the infrastructure materials, substrates used in infrastructure? It can be metal, it can be concrete, it can be a composite like fiberglass, it can be woods, you can be using mild steel, stainless steel, galvanized iron, cast iron, any non-ferrous material as a metal. And when we say concrete, we are using it in roof surfaces, you are using it on walls, you are using it on pillars, what you call piers in the case of bridges, floors, everywhere we are using concrete. Roads, also there are a lot of concrete available, there are bituminous roads as well. So there are a variety of materials used in infrastructure, and every material used in infrastructure is going to wither out. Now, there is a huge cost, there is a loss of material, and there is a cost to it. When you look at the cost, it is something very, very alarming. When we talk about the loss of material during corrosion, we try to express not for the accounted loss of production or any accident or loss of life or loss of material. We only concentrate on the thickness loss of steel. That itself is a whooping 4.5% of the GDP. This is something very surprising. The mindset to corrosion. Many a time, people, even in professional life, do not worry about corrosion till such time the production is stopped. This is what is amazing. When you say 4.5% of the GDP, probably, if we are able to effectively stop it as good as Japan, we will be in a position to give free education to the entire country up to the level of, say, 12th standard or up to the level of engineering, might be. This is the type of money which Indian government loses only by the thickness loss of corrosion, not on the productivity. Please understand, not on the loss which has been created for safety or accidents. So this itself is a huge cost. And you find that there was a fire here or a fire there or a leakage here in the pipeline, or there can be hundreds of examples which we can come across. Everything, there is a point of connect called corrosion. Hence, as growing engineers, I would like to impress upon you that there is a responsibility for us to ensure reduction in corrosion loss by using the proper mitigation methodologies prescribed. So let us learn chemistry properly, let us learn mechanics properly, let us learn material science properly. And there is going to be a huge requirement. And one of the supportive mechanism to lock corrosion is by using paints. How can paint stop corrosion is what we are going to discuss. And when you look at an overall aspect of corrosion management, it starts right from identifying the right metallurgy. The structural strength has to be first defined. The design has to be clearly laid out. And whatever is going to create corrosion, if there is an opportunity for us to reduce by altering the environment or adjusting the process mechanism, that will be a most important work. Reducing aberration, reducing velocity, reducing concentration, or use of inhibitors. There are so many mechanisms which are there. While there are opportunities to do surface modification technologies, there are also coatings as considered as organic coatings which can be applied on these substrates. The other forms of mechanisms are anodic protection or cathodic protection. And this is as per the technology. But when you talk about the management aspects, there has to be a corrosion expert and a protective coating expert who can draw out plans and help them right from the day as a consultant for a project to as a maintenance head or a project head. There are a lot of people available to ensure proper corrosion management. As we all understood, the corrosion depends primarily on the environment in which a substrate is placed. Let us take a quick example of your own home at Kovilpatti or Madurai or Trichy. We are quite inland, so it is a dry environment, and the corrosion rate is going to be quite slow. Corrosion is there. You still find rust in these places, but it is primarily due to the presence of oxygen and once in a while some rain coming up there. But when you have a frequently wet area, humid area, the corrosion rate is much higher. This is understood for a steel exposed as a grill in your window to the grill gate outside of the house. The corrosion rate found there is much higher when compared with the bar in the windows. Both are being applied with the same type of paint called an enamel paint in the colloquial word or an alkyd paint as per the generic terminology. But when you walk into an industry, even in Kovilpatti or anywhere you find a cement industry or a sugar mill for that matter, which is known to you, there the corrosion rate is much, much faster or severe. You find that in a sugar mill, the corrosion rate is going to be close to around 3 months or 4 months. You find some steel getting corroded, and every year there is a painting exercise like a festival once in a year after the harvest. So once the crushing period is over, they take up painting. See, this is how they are doing it in sugar mill. So that is the frequency of painting which happens in industry. In a cement plant, again, there are a lot of cement dust available, and this dust are going to be hygroscopic, and this hygroscopic means it is going to attract water. There is going to be an acidic condition there present, and the steel is going to get corroded fast. No doubt in a marine or a coastal area, what you have is the abundant presence of salt in the air. Even if you go to the beach and lick your lips, you find that salt has come and settled on your lips. So you're able to see salt there. No doubt drinking the water, everyone can say, including a child, but this presence of salt in the atmosphere itself is going to trigger. So if someone has got a house close to the beach or in a marine area, the corrosion rate is much, much higher. Imagine an offshore, just right on the sea. A ship passing in the ocean has a very, very high corrosion rate. Or in other words, in a chemical plant where the acidity or alkalinity is much higher, the corrosion rate is going to be more severe than a marine environment. So this is how there is going to be an increasing severity. And what you can see on the left side, C1 to CX are all the reference standards to make it clear to the international consultant and what atmosphere you are. You cannot say I'm in Kovilpatti. He will not understand. So we have to say we are in C1 weather. So that is how they understand. So that's how we are trying to understand the importance of getting a reference to a standard and equating our atmosphere to that particular standard to know what is going to be the rate of corrosion. When we are talking about any painting done to it, and we wanted a proper life on as a performance to it, we start right from the design of the structure, and then we need to know what is the environment it is going to get placed. We have to prepare the material free from any contamination, right from mill scales to rust to previous coatings. Then we have to get a good choice of a paint, and application has to be made very precisely, and inspection has to be done at every stage. If there is going to be any compromise right from the identification of a proper material to the inspection. No doubt, the service condition also plays a very crucial part. If this is not done, how to monitor, how to record, how to do the repair systems, how to do maintenance plan, how to do it as a preventive maintenance. If this is not done, then we are losing on the valuable material. And end of the day, we lose heavily to corrosion. And this is where we are talking about a science which is not well elaborated even in your engineering books, and therefore they have invited us to give you an insight into the painting activity. Any engineer from the college, if at all he enters into an industry, he is going to be involved as an electrical engineer or mechanical engineer or a civil engineer or whatever, be it chemical engineer. There is going to be an opportunity for him to ensure that his place, his equipment has to be there to give the required productivity. And if productivity has to be ensured, there is a need for coatings or ensuring that the deterioration of the material, be it a pipeline, be it a structure, be it an equipment, be it walls, be it, there can be 100 number of areas, whatever material you touch, be it a plastic, we need to ensure that the corrosion or the deterioration to that particular material is controlled. That's why we try to understand on the importance of paint. When you look at the service conditions that are being handled by coatings, you'll be surprised. We understood the word corrosion. Yes, many of you can look at the electrochemical corrosion. Right from their 7th or 8th standard, you are studying about it. The presence of an anode, a cathode, a metallic pathway, the electrolyte present, and the dissipation and release of electrons from the anode. So all this you people have studied. Now, what is that which is most important is how do I stop the metal from dissolution? Which means I am not supposed to allow the electrolyte to come in contact with the substrate, which is something like a barrier. Okay, so I should create a block. No oxygen passes through, no moisture passes through, no acid alkali passes through, no ions passes through this particular barrier. Therefore, the substrate is well protected on the side of the coating. There is another important area where higher the heat, there is an opportunity for corrosion to be happening. And paint, being a family of plastics, are not going to be normally more than 100, 120 degrees. So that is one of the reasons why in a gas stove you have a small grill on top of it that always is looked as a corroding member. So heat resistance is not part of a paint's normal fighting mechanism, but there are specialized paints which have been used for heat resistance, and it can take to temperatures of 200 or 400 or 600, 650 degree temperatures. And there are paints which we call it as cryogenic temperatures, where it can go up to minus 40, minus 180 degrees centigrade as well. UV resistance, yes, everything. If we are there in the sun, we get tanned, our skin gets tanned, and you become more dark. So this is how it happens. So any material, when it is put on under the sunlight, there is going to be a degradation, and even paint will degrade, which means that the protection is getting lost. So we need a paint which can handle UV resistance as well. Chemical resistance, we have already appreciated the understanding of that. Aberration, yes. Even steel, you just look at the bus where you're traveling. There is going to be a ribbed plate of metal, okay, which has got some protrusions. And while you keep walking in and walking out of the bus, you find that it has become very smooth. The profiles of that particular plate is already withered out, though it is only a rubber slipper or a leather slipper what we wear, that is getting abraded. So stones or metal, for that particular matter, will continue to get abraded. And that is one of the reasons why when you are applying material on a metal or on a silo or on a floor, we require a good aberration resistance, and this is being done by paints. When you say weather, it is a combination of UV or rain or cold or heat, whatever be, or a debris being cyclonic debris like windmills, windmill blades. We are talking about weather resistance. So these are the 6 common and the most important conditions for which a paint is getting applied. But there are certain specialized services as well. When you are putting a pipeline under the ground, okay, the pipeline serves carrying petrol, gas, water, whatever be that, and it continues to serve for more than 70 years, 80 years, like that. How does it work? A normal pipeline, whatever you bury in the ground, it gets corroded in a matter of 1 year or 2 years. Then how are these pipelines serving us for more than 50 years and 70 years? So there is a protection service called cathodic protection, okay, which means there is a sacrificial anode or a current which is coming up on the metal, which is going to stop degradation of your particular material. Now, can cathodic protection be alone? No, they require a coating also to ensure that they are using lesser current. So we are talking about multiple technologies coming at one play. So I'm not getting into the detail because your teachers are going to help you for that. I'm just going to give you a broad idea on where industrial coatings are being used. So it can be on the external of the pipeline or internal of the pipeline, and it can be in combination with cathodic current systems. There are requirements of pipelines in both areas where it goes underwater. And there are immersion conditions, which is called lining, which means you have a water tank in your house, okay? Or you have it in a common area. There is an overhead water tank. The concrete alkalinity is not expected to get into the water. The salts of the concrete are not going to get dissipated into the water, which means that there should be a coating inside of the concrete tank. The coating smell should not get into the water. Okay, it can be a steel tank or a concrete tank, and you have to protect the water. It should not get contaminated. That is what we call it a lining. Wherever you find a tank, be it a storage of your oil, for example, your food grade oil, okay, vanaspati or anything else like that, or be it aviation turbine fuel or naphtha or caustic lime, whatever be the type of material which is getting stored in a vessel or a big tank, okay, the tanks in a petroleum refinery are as good like a football ground, okay, such a big tank you can see. Inside of these tanks, coatings are getting applied. And as we said about cryogenic temperatures, that is under insulation, there are coatings applied. When you wanted to protect a building from fire, we'll check some videos in the presentation. Coatings are applied. When there is going to be a high-end transmission line going up above, we should not get a static hit. Then we are putting rubber mats or something. Instead of that, coatings are applied. Anti-static current to be stopped, coatings are applied. In road marking for retroreflectivity, coatings are applied. So there are a lot of specialized conditions, including, say, for example, under a ship, coatings are applied, which is called anti-fouling. So we have to take care whenever we do coatings to ensure that the coating is not only protecting the material, but it should not harm the environment. When we are doing a coating, we have to see whether it is cost effective. I can say gold is more noble. So for that, I can't give a gold coating in all my steel, correct? Silver is noble when compared to steel. So can I coat silver on all my steel? No, it's not possible. So I have to create a product which is much, much lesser in cost. Instead of even replacing the steel, my coating should be done. So that is how we are working at. Instead of replacing the steel or a concrete, if I am able to coat it, if I am able to protect it for the next 5 years, 10 years, 20 years, 30 years, that is what we are looking at economics. When you say energy, I don't want to keep doing it again and again. I have to reduce the energy involved in protection. So this is how performance coatings are being worked upon, on what coating can be done. Now let us quickly get into what is there in a can of paint, whatever be the paint, which is used in the wall or which is used in industry. You have typically 4 items which we can broadly classify. One as a binder or a resin, okay, or that is the polymer, okay, which is the muscle of the entire structure, right? You have pigment, which is something like your bone. So the muscle and bone is able to make a shape for your body, and that is how this binder and pigment will give a shape to the coating. The additives are one, which are either for the keeping property or for the application requirements. There are certain additives, and solvents are there to keep the material, to ensure the flowability of the product. That solvents, be it water or any other petroleum solvent, is going to get evaporated. That is what we call it drying. So drying and curing are 2 different aspects. Drying is to ensure that once you touch the surface painted, it doesn't get stuck to your hand. And the number 2, once it is cured, it is able to give you the required performance characteristics. So these are the 3 major ingredients we can put it. From 4, we are removing the additive part because that is something which is there. Resin, pigment, and solvent are the 3 important areas. One, which gives you the characteristics of the paint, gives you the toughness, gives you the fundamental properties. It holds the pigments, and the pigment can be an anti-corrosive pigment, or it can be a coloring pigment. Okay, there can be an inert pigment as well. So these are going to be the bone, or what you call the backbone of the paint. Solvents, there are 3 different solvents which are used. One is called the primary diluent, secondary and tertiary. The one which dissolves the resin is called the primary solvent, and the one which is used during stabilizing is called secondary. The word one tertiary is the one which we are mixing it while painting to ensure that you have a good spread of the paint. Now you have multiple coat of the product, one for a primer, and then you build an intermediate coat, and then you try to do a finish coat. The primer gives you the anti-corrosion property, the intermediate gives you the barrier property, and the finish paint gives you the property as required for the service condition. It can be UV resistance or chemical resistance, or it can be soil resistance, it can be bacterial resistance, it can be, yes, we can keep going. So we are not talking color as a primary concept here, because protective coatings are more considered as a performance coating. Now let us understand why performance. Is there performance on your walls? Is it only for color and gloss? No. Whenever we are talking paint, be it on your wall, be it on the wood, be it on the steel, wherever you are applying the paint, it is giving protection. And that is how it is to be considered. Whenever I wear a shirt, there is a no doubt important requirement that the shirt covers my odd parts of my skin from it getting affected by cold or heat, but that is how it protects. But whenever I go and buy, what do I ask? I need a cotton shirt. I need probably a shirt with a blue color and a stripe, something like that. So it is not the color and stripes which is my first priority, but the protection which the shirt can offer is what is my vision. So that is why I buy a shirt. So same way, whenever we do a paint, we are looking at the protection aspect, and subsequently to ensure that there is an amount of opportunity, okay, we are trying to take the color and gloss. Color and gloss is no doubt important. When we buy a car or a bike, we want it to be shining well. So that is also one of the most important priorities, no doubt. But the fundamental thing is color and gloss is there, but here and there can be some corrosion coming up there, or under the paint, there can be corrosion coming up in a matter of a year, means you would not buy that particular paint. So you wanted to take it for granted. Number one, I wear a good shirt, okay, beautiful, colorful, glossy, but whenever I wear it in summer, probably I get a lot of sweat inside. Whenever I wear it in winter, I am getting chilled. So that is not the shirt which I prefer, correct? So it has to give me the required protection. Apart from that, I need to take on certain add-on benefits like color and gloss. Is that clear to all of you? I believe yes, so I carry on. So the protective mechanism for anti-corrosion property can be the pigment as well as the resin, which gives you a inhibition reaction or a sacrificial reaction like zinc. That's what we call GI pipe galvanized iron. So zinc is what is being used in galvanizing. So the same is being used in paint as well, which sacrifices itself to protect the iron. So that is one of the best primers available. When you say barrier, we are using inert pigments like TiO2, titanium dioxide, or micaceous iron oxide. These are the products which are used, or glass flakes or aluminum are used as barrier protection. When you look at the types of coatings, we can call it alkyd coating, rubber coating, epoxy coating, zinc coating, polyurethane coating, polysiloxane coating, polyurea coatings, vinyl coatings. You will get mad if I start listing out the various types of coatings that are available, but each one of them have a very, very specific requirement and use. So let's get into further. It is easier to apply a coating during the construction stage, and it is always difficult to give a coating during maintenance. So we have to ensure that we do a good coating at the construction stage. When you say alkyd coatings, these are enamel paints which we use it at home. There can be multi-coat requirements or single coat requirements which are called as monocoat, which gives you both the primer as well as the finished property. Chlorinated rubber are the ones which are being used in industries, and so these are the ones which can be applied on all the plant exteriors. It can take care of both acidic alkaline environments, particularly the moist environments. So this is a very good paint available, and this is there for more than 70 years. Now that after we brought in epoxy coatings, which has got far better chemical resistance when compared to epoxies, you have got a range of products which can be used on walls, it can be used on floors, it can be used on pipes, it can be used on structures, it can be used on ships, huge array of product. We are having thicknesses of around 20 microns to 1 millimeter. 1 micron is 1,000th of a millimeter. These thicknesses are measured, be it in a wet film or a dry film. So there are instruments available to measure the thickness of the coating as well. When you're talking tanks, roofs, there are specialized requirements. We are not inspecting these areas frequently. It gets corroded. If someone walks on top of it, they are liable to fall inside the tank because of the rust, thickness of rust. So there are specialized coatings meant for tank farms. For Pamban Bridge, we are protecting this for the last 3 decades now. The concrete bridge is very, very stable, and we have taken the technology from CECRI Karaikudi, and this is a 4-coat epoxy polyurethane system. And for Bogibel Bridge, this is on across river Brahmaputra. There are specialized coatings for the concrete piers as well as for the steel. This is again a very, very big, prestigious bridge of India. Bullet trains, we have brought in coatings which can give you more than 30 years and 50 years with gloss, and that is fluoropolymer for all the railway stations. Of this, you don't have to keep on painting. It can go for 30 years plus for the same color and gloss. Chenab Bridge, the prestigious bridge, the tallest bridge in the country, is going to get painted with our products. And this is again an area where frequency of maintenance is reduced. Talking about railway coaches, yes, a lot of coatings have been done. Initially 5-coat and 7-coat systems. Now we have been able to bring them to an epoxy coating with a polyurethane top coat, and these trains right from Rajdhani to all the trains which you find here are now getting protected once in every 5 years only instead of once in every 2 years earlier. So when we talk about the cooling tower, this is something which you have seen when you enter Chennai. Okay, there are a lot of in Neyveli also you find this. This is called natural draft cooling towers. These cooling towers are continuously exposed to water because they have to cool the water. And in this particular place, what happens, if the concrete is not protected, it starts corroding and the structure has become risky. Therefore, we have to coat it when the surface is wet, and there are specialized products to be applied on a wet surface. This is a quick example to show you that a paint can still get applied when there is a flowing water. It can still get cured. That is why it is called wet surface epoxy. Zinc coatings, as I told you, are next to galvanizing. This is a very interesting product. It gives you more than 20 years of performance. Polyurethane coatings are very good and choose us even for waterproofing requirements. This is a product which can take care of ultraviolet degradation. Coatings are available from 20 microns to a millimeter thickness, 1000 micron thickness. Polyurea is a new development. These are all called snap cure coatings. By the time you mix the two components of the paint, it would have got set 15 to 20 seconds. It sets off very fast. These coatings are used to ensure you do not have any leakages, or it can take higher abrasion. So in open canals and conduits, this can be applied. It requires high temperature. It requires around 70-degree temperature to be heated during spray application. It's a very costly product, but still fantastic usage. This is a very interesting video I wanted to show. Okay. Now, polyurea. Now, imagine, gentlemen, paint has gone one step beyond corrosion protection. Now it comes to safety, right? In this particular video, you will quickly see that there is a bunker, particularly in an armed area, say, for example, for defense requirements. There is a bomb blast happening somewhere 100 meters away. The explosion is forcing the air to come and thrash off your glass panes or even the concrete wall, and the person is liable to sustain injuries or death. And these armed people, army forces, are now getting protected with a paint on the wall which will not allow the blast area to come and affect their bunkers. Just look at it. I'm not going to play the full video here, these extra talks. I'm just showing you this. You can see that blast, yeah.
4, 3, 2, 1.
After this blast, okay, that is how the bunker gets disturbed and the person inside. See that? See that? Yes. So what we need to do is to protect our armed people from getting. This is how the paint is able to protect them. There is a blast, one side, another side. The wall, which has been painted with polyurea, is able to take the pressure of the blast. It is able to expand and does not allow the concrete to fall down. This is a very specialized product called polyurea. So paint is able to expand, holding the concrete as well. How does it work? Let us take a different example. I'm pushing it further. There was an area where this pavement blocks, concrete blocks are being coated with this polyurea, and we are trying to drop it from a height. The untreated blocks get broken off. Now you see this, the concrete is very stable. Uncoated breaks, the coated one stays back. And this is a very, very interesting product line. It has a very high strength as good of steel, and it is able to hold on to the material in a very nice way. The brick or the concrete, even if I put it on a watermelon, the watermelon doesn't break. That's how it is. So it can be used on pipes, directional drilling pipes. It can be used on bunkers. The next product is coating under insulation. If there has insulation and corrosion happens inside, it is catastrophic. Whatever material, hot or cold, is going to come out of it and stop the process. A lot of insulations are being done in pharma plants. So imagine what is going to be the catastrophe. So we have got specialized coatings which can take temperatures from -140 to 600, and that is corrosion under insulation. This is another area, your common cylinder. You see, you get it always corroded. We have brought new systems called monocoat systems. We are able to blast it, and this is called abrasive blasting. The old paint is getting removed, okay, and you are getting the metal free from any contamination. Subsequent to that, you are giving a single coat, which is a primer cum finish. It's a polyurethane coating, which does the service of both the primer and finish, a single coat system. And this is going to get adopted in your IOCL cylinders in future. So this is a trial which has been done very recently, and we have taken the approvals, and this is going to come there. So over a period of time, we will create change. They are measuring the thickness in this particular video, what you can see. It's called the wet film thickness. So this is done to ensure that you get the right dry film thickness after the coating. Now, when you see here, SST means salt spray resistance, means it is able to take 1000 hours of resistance, even if you continuously keep pouring salt at more than 5% chlorine chloride concentrations. Now, next, we'll get into flow coatings for hard to reach areas like transformers, fins, and all that. You can pour the material directly into that, and still it gives you a coat for both primers and finishes. There are products which can be applied on stainless steel, aluminum, or GI, whatever be the substrate, the same primer can be used. And even for polished surfaces, there are specialized coatings available. There are coatings available for can coatings and drum coatings. You see, these are all sheet metal getting coated and subsequently, bent and rotated and welded, and they form your cans. And these are all coatings for the caps, where you find some all these type of coatings are coming up, and these are all very thin film coatings, which has to perform not only carrying the material, whatever is written on the label, the printed material, the name of the product, say let it be Coca-Cola or let it be Berger, that name should not get diluted with a spill of contents, okay? And it should not get erased. So there are specialized lacquer coatings which are being applied on the printed material as well. So there is a base coat, then the printed material, then comes the lacquer coatings. This is a very interesting study, how paints are able to protect us from the event of fire. Fire can happen in our buildings, fire can happen in industries as well. But India has a very poor track. We are having the highest number of fire accident cases globally, and this has to be stopped. Means engineers like you are going to get into ensuring that we have the right coating systems when you become a professional. Okay, right now the protection is very, very limited, which is there only in industries. This is required in metro stations. This is required in any high-rise building. You all recollect while you were children, you know that in Kumbakonam, the school, you can't forget it, how many children died even before they were evacuated. So there are a lot of case studies to say how fire can kill us. This is a quick video to show you how fire can spread in less than 30 seconds and you don't have time to get out of your room. So don't ever think of your mobile phone when there is a fire, rush away. I'm sorry, I'll run this video.
In the air. But since most people's houses may have a 8-foot or a 10-foot ceiling, what that means is that those flames are going to hit the ceiling, roll across the room. The heat that's now spread across the ceiling is heating up other things in that room, furnishings, carpet, whatever, and you have a very rapid fire development in the room.
When a fire grows unchallenged, everything that will burn ignites. In this case, only 33 seconds.
So in 33 seconds, you could see that the fire had taken away the opportunity for us to have any vision, okay, which means that you can't even escape. So before that, we have to escape. What happens to fire in a concrete building? We think that concrete is as rigid as a rock. Unfortunately, not so. When the temperature goes up to more than 150 degrees, okay, concrete will start losing its strength and all the water in the concrete will start escaping off. So dissolution of calcium hydroxide happens over a period of time with crossing temperatures of 575 and 800. You have had a very, very serious structural instability, okay, the fire causes. But what happens to people inside the building? At 68 degrees, you have an opportunity to survive less than an hour. When the temperature crosses 100, you have 20 minutes of time. When it crosses 180 degrees, you cannot survive for more than 3 to 4 minutes. So that is going to be the rising temperatures. Be it a concrete building or be it a steel building in a fire, they are going to touch high temperatures in a very short duration of less than 10 minutes and 15 minutes. So we do not have much time when there is a fire bell or a fire alarm. We'll have to run away. Even do not worry about your mobile or your baggage and belongings, whatever be it, cash or anything, just rush out. And that is what is more important. With all the new areas, wherever you go, be it an airport or be it a mall, be it any new office building, please do take time to watch what is a fire escape route, okay, and understand that. If not, it is going to be costing your life. We do not know when and how a fire can come. It can be a short circuit, it can be whatever be the reason, right? So let us look at the fire in a hydrocarbon fire, which is an industrial fire. See the effect of it. This is a true video. Look at the truck. The truck has not created the fire. It was a refinery inside. And you can see the speed in which the fire will propagate around. Yes, that's the explosion happening in the industry. You can see the fire engulfing the entire area in a matter of a few seconds. This temperature is more than 1200 degree temperatures. Any steel will melt. So this is how it is. Steel, when subject to temperature, will melt, and crossing 550 degrees, it loses its strength to hold. And this is where paints are coming to ensure that the steel or the concrete can be protected for a period of 30 minutes, 60 minutes, or even 120 minutes, 180 minutes, like that, 240 minutes. To that length of time, we can ensure that the steel can be protected without the effect of fire reaching it. And that is total insulation to the steel or the concrete. And this is where we are working. We have coatings. You can just see how this coating is being done. I'm running this video fast for lack of time. So this is your structures which are getting protected with this particular coating, right? Even on the spears, this is called a spear. And then you have bullets. All these are being coated with a very special coating, and that is called a fireproof coating system. Now see what happens when, after getting it coated, what happens when in an event of fire. So there is some supposed leak there, which is creating a fire opportunity in the refinery. And the fire has happened. You can see that the steel will be shown as blue color, which means the steel is kept cool because of the fire protection system. So these are all called pool fires. Despite all that heavy fire, the paint is able to protect it from the effect of this fires. So this is a very special coating which has got certification from Underwriter Laboratories, and we can protect the refineries. All the refineries in our country are protected with our products. And this is how the painting is happening. It can be a thin film coating, or it can be a cement-like thick coating. So you can see both the videos. This is like a cement getting sprayed. So we have put a mesh and we are putting a very heavy member of coating, which is around 25 to 35 millimeter thickness. And this can give 240 minutes of protection. So even in the case of a refinery getting into an accident, the human life is being saved. Okay, and that is the importance of doing fire protection. Floor coatings protects the floors. So be it acidic, alkaline, or wear resistance. We are having, or even hospital floors have to be for clean rooms. We are having floor coatings for that. This is a quick video. I don't know how much time we have. We are already touching 3:05. So we may have to take another 5 minutes with your permission, madam. Is it okay?
Okay.
Yeah, thank you. This is to give you a quick idea of how floor coatings are getting applied. This is a product which is like your vacuum cleaner, but not so. It's a diamond cutter. It is grinding the floors, and then there is an application of they are removing all those dust particles using a vacuum cleaner, industrial vacuum cleaner. Now they are filling all the cracks, and all the grooves are getting filled with material. Then this is a primer which is getting spread, and this will give you around 40-50 microns. And now this is a process called broadcasting, where they are putting an amount of aggregates to give you the roughness, and subsequently they'll be doing a floor coating which is applied at a 2 millimeter thickness. So this can take heavy duty floors, more than 20 metric tons of load it can take, and these are going to protect your concrete for not less than 10 to 15 years. These are all specialized coatings for the floors. There are a lot of applications for floors. Your tiles is not required. Okay, this is a seamless continuous material. That's it. And going to the next line of product, these are all various applications on floor coatings. And this is called road marking. Even on I'm just switching on the videos. This is a hot melt application. You have glass beads getting sprinkled on it, and during night you are able to see the light. It's just because of a headlight. I'm sorry. So there is no street light here. You can see that the white lights are being made visible just because of the reflection of your headlights from your vehicle. This is called retro reflectivity. This is being done by the glass beads, and superior aberration resistant offered by the paint. So this is again paint which is getting applied on the roads. Even in airports, for having a visibility for the pilot, we have got a high index glass bead applied on the runways. Talking about curbs and medians and aprons, these are all application done using a specialized equipment where we are able to spread the paint at a very fast way in an airport. And this one you can see on the curbs, we are able to give automatic spray, giving the required width also for the yellows. Now only the black is getting coated. So the next application they'll be doing the yellow lines. So this is how fast we can do this painting in a high traffic zone. And we have color bank systems where you can find colors which can be done to your requirements. So this is called a gyro shaker. You put the paint, it is all available in neutral colors. You put the required color in it, put it into this machine, and it mixes it, and you're able to get a range of colors. And the most important point of all of it, skill of painting is very important. Berger runs a CSR activity. We do training for industrial painters. This is done free of cost, and we have been well appreciated by the industry for doing this. We have got a lot of mechanized tools, and this can be reducing the dust and increasing the speed in which we can apply. And we have also been the first company in the world to say paint company getting connected to developing a software to teach painting. This is done in Chennai. You have it in Ambattur. Anyone who wants to have a hands on it can go there. It's called a simulator. You don't use paint, but you use all the tools which is meant for paint. You are able to see a spray booth. You are able to get the learning of how to do a spray painting. Our Prime Minister Modi ji had an opportunity to see this during an IIT festival there, and we were able to showcase this particular product to him and see his curiosity. He will wear the virtual reality simulator and he will paint himself to see how effective it is. This has been approved and being used in our National Skill Development Program. Thank you very much for all of you and for the time given and opportunity given. Thanks to Pulse. Any questions? I request the volunteer to open up and open the questions. We'll be there to give you the required answers. Hope we were on time, I believe. Yes?
Yes. There is no questions in the chat box. Anyway, we'll wait till the end. Now the teams will present their presentations.
Okay.
MCs?
Thank you, sir, for sharing knowledge. It's time to invite the first team from National Engineering College to present their ideas.
Good noon. Hello team, happy to join you for this presentation. We, Shivani, Vishnu Bharati, Mudasar and Prasanshya are probationers under the guidance of Mr. Gautam, Assistant Professor, Civil Department. We are glad to present our National Engineering College, and I'm Shivani here to share and gain some knowledge about this presentation. Today, the topic we are going to discuss in the screen it is bridge, flyovers, concrete and steel structures. Do they need to be painted? The answer will be concluded at the end of the presentation. Next slide. Structure. Now, what is structure is, it refers to anything that is constructed or built from different irrelated parts with a fixed location on the ground. Bridges, flyovers, canals and tunnels. Other than this, I'll say anything that is built on this planet is a structure. Next slide. So getting into the topic, why do these structures need protection actually? Let's be generous here. Every materials, products and even every person in this world will have some defects irrespective of their quality and quantity. Everything in the world will have some defects. Now, unlike that, these structures will also have defects irrespective of their quality and quantity. Instead of being generous, these are the defects of concrete and steel structures. In concrete, the concrete can be porous so that the chemicals can penetrate the pores and attack the paste. The texture of concrete can be anything that is heavy grained, rough, non-slip, light polished, and all these will have pores. Everything that is invading inside us are foreign materials and not good for us. So don't open to others. Here, these pores are the major defects in concrete structure. Rather than this, concrete structure will be attacked by carbonation, chloride attack and sulfide attack, and these are the factors that is influenced by atmospheric exposure of reinforced concrete. Next slide. Getting into steel, we all know the locus of a circle, that every point connecting around the circle led to the center of a circle. Just like that, every defects connecting around steel will ultimately lead to rusting. Corrosion. Corrosion is the only main defect of a steel structure, and this steel will rust only in the presence of water and oxygen and greatly accelerated by the pollutants like sulfur dioxide, carbon dioxide, dust and humidity. The problems are discussed. That's all with the problems. And what is the solution? These are hints when connecting all these defects that given absolute and solution to the problems. All the defects I mentioned were surface defects. That is, these defects will ultimately affect the surface of the structure from inside out. So the solution is very simple. Coating. Next slide. Yes, coating is the best solution for any surface that affect the structures. Coating the surface with any specific material that actually protects the surface from being affected will be the best solution here. When I mention any specific material, this slide shows the types of specific material that is technically called the types of coating. Barrier coating, inhibitor coating, galvanic coating, acrylic and alkyds coating, epoxy amine coating, epoxy coal tar coating, epoxy fusion bonded coating, inorganic zinc primers, polyurethane and urethane coating. Many among them are the solutions for our problems. Next slide. So, apart from all the other general solution, why choosing the absolute solution, that is painting? Because it provides protection against harmful agents and thereby increasing the durability and also to provide aesthetic appearance to the structure. Other than that, it is a good adhesive. It resists harmful pollutants like alkalis, carbon dioxide, sulfate and chlorides. It also gives resistance from UV exposure and thereby preventing the fungi and algae growth, etc. Next slide.
Okay, she discussed about that why we need coating. Actually, coating was applied to the surface of any object. Referred it can be the purpose of coating may be of decorative or as a functional. Paint is the most commonly used coating, and it can protect the steel from rust and concrete from any barriers. Thus, construction of and conservation of structural integrity can be achieved during its service life. Protective coatings act as a barrier by protecting steel from rust. And these are some information. And this is an strength of the painting will be as paint protects it from high salt content in air, which can cause the steel to rust or corrode. And weakness of paint is while painting a structure, it can cause an extra cost to the structure. And I think so that no threads were being found out till date in paint. And these are the components of paint. There are solvent, resins, and pigments. Actually, solvent and resins are the type of components of two main coating has two main components. That's vehicle and a pigment. And the vehicle is classified into a solvent and resin. Actually, organic solvents are formulated into coatings to perform three essential functions: dissolve the resin component, control evaporation for film formation, and reduce the coating viscosity for ease of application. Solvent will also affect the dry film adhesion and durability coating properties. In general, resins are less soluble, will require neither more solvents or stronger solvents. The term solvents are often used where it can have two usage. It can be used as a coating formulation to the predetermined concentration level of the structure getting corroded, or as a second, it can be used for a cleaning solvents in strong concentration strength for cleaning brushes, rollers, and hoses. And resin is frequently called binder, is the film forming component of a coating. Resins are typically a high molecular weight solid polymer that forms large repeating molecules in the cured film. The properties of resins may be of mechanism and time of curing, performance in surface exposure type, and performance on substrate type. Substrate means the surface of the structure, and exterior weathering and adhesion. Pigments are insoluble or a heavier solid portion of coating that typically settles at the bottom of the container. Pigments are additives to the coating formulation that impart special properties to achieve the desired film properties. And these are the applications of paint. That paint can be done in a structure through brush application and a roller or as a spray. And brush application is used for decorative coating of relatively small and complex areas. Brush painting is a slow application method, but it provides a good penetration of the paint. It prevents the paint losses associated with the spray application method. And next is our roller application. Roller technique is applied for a coating that are large flat surfaces. The method is faster than brush application. In contrast to brush method, roller painting is not suitable for applying high film build. And spray application. In the spray application method, the paint in the form of atomized droplets is delivered by a stream of compressed air. The paint is pumped from the tank into the gun, and it can be done by the compressed air method. We also have two types, that is airless spray and electrostatic spray. And next will be considered my team member.
So let's see what the types of concrete and steel which is used to build structures. So concrete is one of the most frequently used building materials. Its usage worldwide 10 for 10. It's twice that of steel, wood, plastics, and aluminum. Next slide, please. Next slide. Yeah, why we need to paint concrete? Paint concrete certainly has its advantages. Concrete paints and stains help to mask surface discoloration and signs of wear and tear, and extending the life of concrete by preventing further damage. Coating a surface with paint can also make for easier cleaning and maintenance. Protective coatings used for exposure concrete surfaces have become essential elements in construction projects, especially in harsh environments of concrete, because corrosion of steel reinforcement inside at which it harmful to concrete. Durability of even good quality concrete can suffer due to persistent chemical attacks, abrasion, freezing, and thawing, etc. If coatings can, I'll just move to a place. That's where the relevance of protective coatings come into this picture. These coatings pose as shields between the concrete surface and the surrounding environment and protect concrete from harmful effects. Protective coatings are usually made of resins, pigments, and solvents. There are solventless protective coatings as well. It is the resin component that provides the protection while pigments impart colors. Protective properties of coatings are sometimes further modified by adding suitable filters and depending upon their requirements. Some examples of protective coatings are epoxy coatings, polyurethane coatings, vinyl coatings, polyester coatings, and so on. Protective coatings are useful for varieties of structures such as bridges, decks, abutments, heavy-duty industrial floors, or industrial concrete surfaces subjected to chemical attacks or harsh environment. Water and wastewater tanks, marine structures, manholes, even a lot can be used here. The defects in concrete has been already explained. To prevent this, we can use certain paint coatings that were the next slide, please. So carbonation is one of the main defect which is caused by concrete, and even carbonation can be prevented by using paints. So what is carbonation? Carbonation is a process by which carbon dioxide from the
a gentle reminder for team
Carbonation of concrete is a process by which carbon dioxide from the air penetrates into concrete through pores and reacts with calcium hydroxide to form calcium carbonates. It has been seen that conversion of calcium hydroxide to calcium carbonate by the action of CO2 results in a small shrinkage. In the presence of moisture, CO2 changes into dilute carbonic acid, which attacks the concrete and also reduces alkalinity of concrete. In actual practice, CO2 present in atmosphere smaller or greater concentration penetrates into concrete and carbonates the concrete and reduces the alkalinity of concrete. So this can be prevented by the paints. Paint fills the surface pores and bridges fine cracks and forms a barrier to the movement of carbon dioxide. It is measured by carbon dioxide diffusion, which is defined as ability of the coating to resist the ingress of carbon dioxide and to stop the carbonation of the concrete. Next slide.
Thank you. Hello, everybody. Thank you very much, Anto, for the information about concrete. Now it's time for steel. Steel is also one of the most important engineering and construction material, as we all know it. It's majorly made from, it's an alloy, actually. It's an alloy of iron. So it's the main content and main constituent is iron. So if wherever there is iron, there will be rusting. That's obvious. So here we need to know about, as sir already told about the rusting of iron. So there will be corrosion. So for corrosion, we need this, next slide, please. Protection, we need protection. So for that, one of the most commonly used material for the protection of the steel is paint. So it's the most important reason for to protect the huge financial investment by means of corrosion prevent. Sir already told about how much loss this because of corrosion, how much money it takes, how much capital it takes, and so to prevent this thing, we mostly use one of the economical method, that's paint. It also this prevents from the chloride attack and provides aesthetic appearances. Next slide, please.
Your time is up.
Okay, sir. So should we conclude, sir, then, or just
quickly finish?
Okay, sir. So our topic actually was that should we paint the steel and the concrete? So the answer is that we should paint concrete and steel as to protect it from the corrosion and to protect concrete from the corrosion or other chloride attack and carbonate attack. That was the main topic. So thank you very much. Maybe Shivani was going to say something or not.
Thank you.
Thank you, team, for your presentation. Now I invite the second team from Tyagaraja College of Engineering to present their ideas.
Please keep to the timing.
Stop sharing.
Yeah, stop sharing, and please keep the time.
Thank you.
Thank you.
I hope the screen is visible.
Yes.
So, good evening. Myself, along with me, I have my team members Karthikeyan, Kribagar P, and Pranav M. Okay, we are here representing Tyagaraja College of Engineering, and our topic of discussion is challenges in water carrying pipelines and whether it should be painted or not. So, let me first take you through an overview of paints and painting. Okay, paint was one of the earliest inventions of humanity. It is the most commonly used to protect the object or color it, that is an aesthetical appearance, or provide a texture to an object. Most paints are either oil-based paintings or water-based, and each of these have a distinct characteristics. Water-based paint and oil-based paints will cure differently based on the outstanding ambient temperature of an object being painted. In fact, it is illegal in most municipalities to discard oil-based paint down household drains or sewers. When speaking about painting, safety and protection indirectly comes into action, and lots of materials requires a protective coating to prevent against climatic, physical, and chemical changes. Few of the materials are metal, concrete, and plastic, etc. Is painting necessary for pipelines? So all above ground, underground, and underwater piping system needs a protective coating that can help prevent rust and corrosion. Over the years, innovative product has been developed to address the issue of rust and corrosion in pipes due to different environmental factors, elevated temperature, moisture, and salinity level to acid rain and chemicals. Before looking into the protective coating, we have two considerations. Firstly, the physical coating, physical location of the pipeline. When accessing the location of pipe system, the humidity, temperature, and UV radiation level, etc., all comes into the picture. And secondly, the atmospheric corrosivity. As Sir said, according to ISO 12944, we have 5 atmospheric corrosivity, C1 to C5, where C1 is for heated buildings like office buildings. This is very low. C2 is low, which is non-heated buildings with high humidity. That is, for example, warehouse. C3 is medium, so building with high humidity, high air contaminants. C4 is for chemical plants, and C5 is for industrial environment. The above two factors will detect the type and level of surface preparation required and the type of paint that can be used for a particular application. So apart from the above, we have different color codes that are painted for different applications. For example, blue pipes denotes the potable water. So here are few images of the different color codes of the pipes. So I call Pranav M to explain about the benefits of painting pipelines.
Thank you, Abhinav. And coming to the benefits of the painting in pipelines, there are lots of benefits when we are painting the pipelines, for especially when pipelines carrying the potable water. First of all, the cost. Whenever there's a consideration of cost, painting includes a large cost. Yes, I accept it. Yet when the pipelines are not painted, they get rusted and the cycle time of the pipes get even reduced, so that the change in pipelines will be very much faster than when pipelines are painted. So painting the pipelines will extend the life cycle cost of the pipelines and also extend the life of the pipelines, so that the operational and the maintenance cost of the pipelines will be reduced. Coming to the quality of the pipelines, the quality will be increased in a very vast manner when pipelines are painted in both external and the internal surfaces. While painting in the internal surfaces, it also maintains the hygiene of the water, and the potable water gets microbial resistant and gets safely transmitted. In case of environment, when overground pipes are exposed to environmental conditions, they get rusted in case of steel pipes, and in case of underground pipes, they get rusted due to soil moisture. And when pipes are painted, these pipelines are resistant to the rusting process and also other chemical reactions and becomes chemically inert. So as a result, when pipelines are painted, they get more durable, and as mentioned before, it is resistant towards the chemical actions from water and also from other fire accidents. Next slide, please. So painting in metal pipes. As we all know, metal pipes undergo a major problem called corrosion when left in atmospheric moisture. So corrosion occurs due to the environmental factors ranging from high temperature, moisture, and salinity levels to acid rains and the chemicals. So mostly metal pipes used for potable waters include copper pipes, galvanized steel, polyvinyl chloride pipes in case of local transmission of water, and chlorinated polyvinyl chloride for more efficient transmission and including the hygiene of the water. And the cross-linked polyethylene PEX pipes are used for potable water pipes. Non-ferrous pipes are mostly not painted because they are somewhat inert to rusting actions. So in case of rusting, both in external and internal surfaces, rusting happens. In external surfaces, rusting happens due to the atmospheric moisture when in case of overground pipes, and in the internal surfaces, it happens due to the water present inside the pipe itself. So now I call upon Karthik N to explain about it.
Thank you, Pranav. Now I discussed about the external protective coatings for the underground pipe and the pipe above the ground. Generally, the potable water pipes are subjected to acid rain, abrasives, and other environmental factors when it lies above the ground. So coatings are the best way to protect this corrosion and other environmental factors. Fusion bond epoxy coatings are preferred in olden days, but in nowadays polyester and they are in covalent in nature, so they are preferred. And the thermoplastic resins like polystyrene, and they are mixed with the solvent lacquer. They are used for the coatings. They are coating by the sprayed methods. And the buried pipes are protected from the soil moisture corrosions from the cathodic protection, and some of the examples like Zinc-Rix epoxy paint and polyamide epoxy, they are versatile corrosion resistance, and the siloxane epoxy coating, they are very good acid resistance, and aliphatic acrylic polyester are good weathering in nature. Next. These are some of the external chemical additives that can be used while coating the paints. Zinc-rich epoxy coating or high adhesion, and the poly epoxy coating, I said already. Amine epoxy coating, these are Novalac and abrasion resistance, and siloxane epoxy coating I said already. The rest of the things, internal coating and the standards for the coatings are explained by the Kripakar.
Thank you, Karthik, and good evening, one and all present here. So let's see about internal coating. Why internal coating is necessary? As water flows inside the water, corrosion occurs very fastly. So due to corrosion, the rust materials mix with water, and it causes some health issues for who are consuming it. So here comes the need for internal coating. In industries, internal coatings are mostly called as linings. So when the water passes through the pipelines, there is a chance of corrosion from the inner side of the pipelines rather than atmospheric moisture. As sir and friends mentioned, the corrosion is a most important factor for considering the internal protective coatings. Next slide, please. So there are some standards used for internal protective coatings. The standards start from material to be used for internal coatings. These standards are given by National Sanitation Foundation of America, and this includes protective barrier metals, which includes cement paintings and coatings, and joining and sealing of materials like adhesives, caulks, lubricants, which are used to mesh the tube pipes, and pipes and related products like pipe, hose, fittings, etc., mechanical devices, plumbing devices, process media, and non-metallic potable water materials. All these have perfect standards to be used in used for coating. Next slide, please. So there are also some standards for testing the coating materials, like C203 is for a coal tar enamel lining for steel pipes, and C205 for cement mortar, and C210 for liquid epoxy coating system, and C213 for fusion bonded coatings, and C222 for polyurethane coatings. These standards are set by the American Water Works Association, AWWA. So next slide, please. So coming to the materials used for the coatings, I first start with the coal tar enamel. The coal tar enamel, which forms the basis of the basis of the coal tar enamel, consists of a stable molecules that are formed during the cooking operations at 1300 degrees Celsius. These have certain advantages like water resistance, stable chemical structure, resistant to cathodic bonding, and adjustment, etc. But there comes a limitation of cost. It is highly costly to implement this coal tar enamel. Next, coming to the cement mortar. Cement mortar linkages provide long-term protection at lower cost and remains one of the standard lining for a potable water. But coming to the disadvantages part, if a flow velocity is increased, the cement mortar is quite unuseful in this case. The major advantage of it is the ease of application.
Sorry to interrupt. 5 minutes remaining. So please make it quick.
Yes, ma'am. I will run quick. Liquid applied epoxy. Liquid applied epoxies have excellent water and chemical resistant properties. And fusion bonded epoxies. Fusion bonded epoxies are one of the part which are height curable, and they are also part of liquid epoxies, which are in a powder form. When they are sprayed on it, they will liquefy fastly. And polyurethane, the aromatic polyurethane are 100% solid materials that contains no VOCs. Polyurethane linings are typically added at a 2 mils minimum thickness. However, thicker lining applications are possible. With this, I hand over the session to Pranav.
Thank you, Krupakar. By referring a recent journal on the analysis of heavy metals leaching from internal pipe cement coating into potable water, we have come to a conclusion that in the early 70s, mostly the epoxy resins have been used. By some of the authors have developed a mathematical model of the heavy metals leaching from the internal pipe cement coating into potable water that included sorption inside a porous cement coating and diffusive transport into a liquid phase. So the mathematical model developed by the authors was experimentally verified for static conditions where the water was placed inside pipeline statically. A high correlation coefficient was observed between the experimental and the calculated results for chromium and lead migrating from the cement coatings into the drinking water. So the experimental and the numerical test showed an initial sudden increase followed by gradual decrease of chromium and lead leaching from the cement coating into water. The equilibrium concentration of both chromium and lead in water inside the pipe were reached after more than 20 days and are equal to about 2.0 microgram per decimeter cube. So they have come to the conclusion that by increasing the pipe diameter twice as large reached as almost twice a small value of maximum cross-sectional average chromium concentration. So over time, the differences between average metal concentration inside the pipes of different diameters increased and reached almost the same value, that is the 2.0 microgram per decimeter cube after 20 days. So from this, they have concluded that using the cement coated pipe internal coating in cement, the water will be hygiene and will be transported to the people without any microbial actions and chemical inert. So we conclude that painting the external and the internal surface of the pipelines is necessary so that the pipelines will also be extended for long life and the water transported through the pipelines will also be efficient. Thank you.
Thank you, KTC.
KIT team, I
Sir,
request.
I'm ready.
Yeah, please project it.
Good afternoon to one and all present here. I'm Praveen Kumar S. from the team KIT, here to present before you a discussion on a tricky yet thought-provoking topic. Before I start my presentation, I would like to thank the Vice Chairperson, Principal, Vice Principal, HODs, Deans and faculty members of KIT for being our pillars of support, and a special mention to our faculty coordinator, Arimani Ravanan sir from the Mechanical Department. Moving on, let me introduce my team members. I'm Praveen Kumar S. here from the second year of Agricultural Department, followed by Bhavya from second year CSE Department, Kribakaran from second year Biotechnology Department, Devi Bharati from ECE Department, finally Shwet from first year ECE Department. Let's move on to the presentation. The statement given for the presentation is, can paint be one among the materials to protect human lives in the event of fire accident? If this is the question, then our answer is obviously yes. Paints can be one among the material to protect human lives from the fire accident. Yes, there are some paints that can withstand fire for a certain period of time and helps to save huge losses from the fire accident. We'll get to know more about these paints in the upcoming presentation. First of all, what is a paint? How were they invented? Paints are decorative colors to decorate walls of household, industries, and many types has been discovered by the ancient human race thousands of years ago. They have developed different colors of paint from the color pigments of flowers, leaves of a plant. What the paints are composed of? What are the main constituents it has? Paints are composed of pigments, binder, extender, additives, and solvents. Pigment presence in the paint provides them different shades of color and opacity, as I said earlier. There is a resin called binder that holds the color pigments in place together. Extender improves adhesion, hence providing the paint's ability to stick to the materials it is being coated with. The major constituent of the paint is solvent. Based on the solvent, paint can be classified as aerosol paints, water-based paints, oil-based paints, and many more. Here the solvent is thinner, which is an organic volatile substance used to reduce the viscosity of paints. Additives are also used to improve and modify the properties of liquid paints. We are going to talk about paints that can resist fire, that can withstand fire. But the point to be noted here is solvent thinner. Thinner is an organic volatile solvent, but at the same time, it is inflammable. Then how come a substance like paint having an inflammable constituent as solvent can withstand fire? How they can act as a lifesaver during the time of fire accident? Is that really possible? Yes. Using paints that are fire resistant is considered to be a passive protection measure. These paints can be classified as fire resistant, fire retardant, and intumescent paints. Fire resistant paints are paints that are inherently resistant to fire. It acts like a barrier between the fire and the material that is being coated with it. Fire retardant paints are not naturally inherent, but they are chemically treated to withstand fire. Intumescent paints plays a major role in industrial aspects and are used in a wide range. Moving on, here is the fire retardant paints. The main purpose of these paint is to stop flame and spreading of fire. This is actually done by releasing some fire dampening gases when it comes to contact with the fire. What's the actual process behind the releasing of fire dampening gases? It will become a major question. Spreading of fire is considered to be a chain reaction occurred by some free radicals in the atmosphere. When the fire retardant paints applied over a surface becomes hot, it releases fire dampening gases that are chemically inert, majorly the noble gases. Further, these noble gases react with the oxygen content in the air and releases some active radicals. Active radicals combines with the free radicals in the air, breaking the chain reaction, and spreading of fire stops abruptly. Here in this slide, we can see a picture that has two similar cases of materials. Here are two ladder cases and two sheet-like materials. One of the material surface is being coated with fire retardant paint, while the other is not being coated. When both the structures get in contact with the fire simultaneously, the reactions of both the materials are being different. One that is coated with the fire retardant paint becomes smoky, while the other that is not being coated burns rapidly. This picture infers us the efficiency, impact, and importance of fire retardant paints precisely. And the result of using fire retardant paints also becomes obvious. Next, moving on to intumescent paint. The main purpose of intumescent paint is to protect the material it is being coated with. How it is being done? When this paint surface encounters any rapid change or it gets in contact with the fire directly, the paint surface starts swelling and forms a thick layer of foam that acts like a barrier to protect the materials. Looking into the picture, we can get a clear idea about how actually these kind of paints work. When the surface of paint applied over a material comes in contact with the flame, it starts swelling. We can see when the temperature gradually increases from 250 degrees Celsius to 450 degrees Celsius and from 450 to 650 degrees Celsius, the rate of swelling becomes faster and the barrier-like layer becomes thicker and larger. These paints can withstand fire at a range of temperature from 120 degrees Celsius to 350 degrees Celsius. This is an example of how the intumescent paints works over a substance like steel. The paint surface starts swelling and forms.
I'm sorry interrupting. It is not 350, it is 1200 degrees also. Okay, carry on.
Okay, I'm sorry, sir. This is an example of how these paints actually works when applied over a substance like steel. The paint surface starts swelling and forming a bulge layer to protect the steel. Hence, these paints are majorly used to protect wood, household, industries, structural steels, air maintenance, aircraft maintenance, and shipbuilding industries, etc. since 1970s. This picture perfectly interprets the importance of using intumescent paints. The paint surface starts swelling up to 50 times of its original size to protect the material when it comes to contact with the heat. Hence, not only being decorative, these paints also provide some safety. The amount of smoke produced, decreasing the intensity of fire, slows. What the intumescent paint is actually composed of? It composed of 19.8% of flame retardant, 15% of dehydrating agent, 18% of foaming agent, 7.2% of resin binder, and majorly the solvent is 40%. But there is an toxicity a lot in the usage of these kind of paints, because these kind of paints also have disadvantages. They used to release some toxins in the air we breathe, which is slightly harmful. Hence, using these kind of paints with the directions of experts and handling them with care is highly suggestible. Finally, by using these kind of paints, 30 to 240 minutes of testing around to frighten of the fire, to fight the fire, and to flight away from the fire. Saving lives is not about huge efforts and sacrifices. Sometimes it's all about tiny acts and tiny efforts with great impact, and together we can save a life, definitely. That's why we are saying, yes, paints can be a lifesaver at times of fire accident. Here are the references for the coated materials. And this is Team KIT signing off by thanking everyone for this wonderful opportunity to be a part of this event. A special thanks to the IIT PALS committee for providing us a sheer guidance and helping us throughout the event. This event became a great opportunity for all of us to gather some knowledge about paints. We could get immense knowledge about paints, and to be honest, our perception towards paint has completely changed. It's not just a decorative element, but a true lifesaver. I'm thanking everyone for making this happen. Thank you.
Thank you, team. This was a nice presentation. And this concludes the presentation of all the teams. And finally, it's time for the most awaited open-ended question and answering sessions.
Mr. Ravichandran, I got the question through the registration form. One question, Dr. Satish from Alim. Shall I ask the question, sir?
You can read it out, please.
Yeah, appropriate paint for corrosion resistance at elevated temperature.
Corrosion resistance at elevated temperature. Right.
Yes.
There are new technologies for this. There is an inorganic copolymer matrix coating which has been developed up to 650 degree temperatures, and it can also handle corrosion resistance. One of the products which is used as an inorganic zinc silicate can take care of corrosion resistance and heat resistance up to 400 degrees centigrade. So these are the two major products which has corrosion resistance and heat resistance.
Okay. One more question from the chat box. I don't know whether you have answered already. What is happening in gem protection paints?
What is that? Please I did not see that.
It was in middle. It was there. What is happening in gem protection paints? That is the questions. Gem protection. Yeah. GRM. Gem protection.
Germ protection.
Germ.
Okay. Yeah. Fine. With respect to this, we have brought coatings called clean room coatings. It can be applied in hospitals, pharmaceuticals, and it is being used widely. These are products which can be applied on steel as well as on concrete surfaces. And typically in hospitals, we use it in operation theaters and post-operative wards and in ICCUs and in pharmaceutical plants as well. What are they doing? Typically, what happens in a hospital is you do a process called fumigation. Okay. This is to kill the bacteria and virus present in the atmosphere, and anything which is landing on the surface of the wall or on the floor. If there is going to be an opportunity for it to breed and multiply, then it is creating an opportunity for secondary bacterial attack. And particularly when the patient is in an operating table, like his wound is opened up, his stomach or any part of the body is opened up, then these type of opportunity for the bacteria to go inside is becoming much higher. So they do a process called fumigation. This fumigation is quite difficult because you have to leave at least 48 hours to continue with this operation, and it's quite difficult. We'll have to check the surfaces. What happens is the bacteria which are there multiply very fast because they get very good climate, an air-conditioned climate, and also they have food for eating from the wall, which is a cellulosic material. Cellulose is part of the wood, okay, so it gets food also. So you get a good food, good atmosphere, so it multiplies faster. In 20 minutes, it becomes double. So we are now bringing paint where there is no food offered to the bacteria. So we have also did it with a lot of bacteria and virus, and we have tested it that if by any chance, by a sneeze or something, bacteria falls on the wall or on the floor or any contamination happens, these bacteria do not have wings. They can't fly around. So they have to stay there, and they don't have any food and they starve. This is how it is working. We do not put any antibiotic into the paint, but by nature, this particular paint is having an opportunity to disallow any propagation of bacteria, and that is how these coatings are working. So these type of coatings are also having special properties, like you can use solvents, you can use water, you can use soap solutions, you can scrub the wall, you can clean the wall. The paint doesn't come out, and it stays there for 5 to 7 years also in the wall or in a steel, and it is able to give you the protection. So these products are called clean room coatings. It is a water-based epoxy and a water-based polyurethane coating system.
One more final last question. How the transparent coatings were made, what pigment is added there, and which coating area you prefer?
Normally, we do not add any pigment. Normally, we do not add any pigments in a transparent or a clear coat or a lacquer finish. It's typically the resin. And in some cases where we need to give an amount of extra protection, we add glass beads. This was answer.
Okay. Which coating area you prefer as a future of coating, and why, sir? That is the final question.
Super water-based coatings, solventless coatings, where it can reduce the volatile organic content. Any paint will give an amount of volatile organic content. So you go into a house, even if it is a water-based paint, you say, oh, you have painted it recently. Oh, that means there is a VOC coming out of that. So it takes a long time for VOCs to get away from the coating. And in an enamel paint, you don't have to ask it. Only around 30% is solid, 70% of that is VOC. All these are harmful for the environment. So we are recommending solventless coatings. We are going in more for water-based coatings, which has reduced solvents. And we are also going in for very advanced coatings like super hydrophobic coatings and clean room coatings. And these are the future technologies which are coming up in the market.
Okay, so thank you, sir. Before going to vote of thanks, participants, I will put the, you have an online quiz and a feedback form. So I'll post the online quiz and feedback in the chat box. Please type the feedback as well as you just attend the online quiz. So you will get a prize for that. So that's it. I request Mr. Arun Dev to propose a vote of thanks.
Hey, good evening, everyone. That was a very interesting session. Thank you, Dr. Kamal Selvi and Dr. Balasubramaniam for your introductions and your kind words on the PALS initiative with colleges. I also appreciate you taking the time to sit through this whole session. The three topics that Mr. Ravichandran had suggested for the students are very apt, especially in today's world where we're talking about smart cities. A lot of this about concrete, painting in concrete, about painting in potable water pipelines, as well as in fire accidents, etc. These all become relevant, especially today. I'd also like to thank Dr. Ravichandran for the very informative session that he had about the products, not only about products that the company makes, but also their applications and how these things are being developed and improved upon. It's a very important aspect in our economy. I mean, I did not know for certain. I mean, this 5% figure of the GDP was a very shocking figure that you threw up, sir. I did not think that corrosion was such a big issue. But now that we know it, I think all of us, and especially the students who are coming up through the ranks, would be more appreciative of the importance of controlling this. So thank you very much for that. I also like to thank the faculty who have helped the students in putting together the presentations today. At least it provides the added incentive for students to do some more research on their own and put up something. And as concluded by the student from KIT, I think they got a lot more than what they would have learned from a textbook, even if it was in a college curriculum. So these are the main things. I like to compliment the teams. They were very excellent presentations, very relevant, very focused as well. So thank you very much for that. And of course, finally, I always forget this, but this time I'll make sure the MCs, thank you for making sure that everything went on time. We are just about 4 o'clock now, so we are dead on time. Thank you very much. And thank you, Mr. Ravichandran, once again for your excellent presentation.
Thank you for your words. Thank you very much.
Thank you, Mr.
Any
Ravichandran.
words from you? Sorry.
Closing remarks. Closing remarks from Ravichandran as well.
Thank you, Mr. Ravichandran, once again.
No, I wanted to know whether.
Presentation, sir.
Yeah, he sent a lot of chat messages, but if you would like to tell something in summary, that will also be good. Ravi?
I think he sent it on the chat.
Yeah.
Thank you, sir.
I am very happy joining all of you, and it is really a pleasure to be with the students and the academicians. I am sure that this interaction is going to create not only awareness, but an inspiration for them to walk into the industry with a lot of confidence and continue their service to combat corrosion. Thanks to all the teachers and to PALS.
Yeah.
Good day to all of you.
Yeah, I look forward to work with you anyways.
Yes, sir.
Thank you, madam.
Yeah.
Thank you for organizing such a wonderful program with Ravichandran sir. Today we have learned many things related to paintings and research work involved in paintings. Thank you, sir. Thank you.
And our perception of students have also increased multifold because for the type of work they have done in the background and then come up with this kind of a thing. I think the colleges have just opened for them. Physical participation is allowed these days, so probably they were able to interact better in the college.
All three presentations are very good,
Very
right?
nice. Yeah, very nice. Yeah.
I think you all read my comments in the box. I was appreciating each one
We
of you.
did, sir. We did. We followed, and it was very nice of you that you promptly gave them on the spot appreciation. Very good.
Yeah.
It is really good. Fantastic.
Thank you. Thank you.
Thank you, sir.
Very good, sir. Thank you.